Hello everyone. In this presentation, we are discussing about highway economic analysis. What is highway economic analysis stands for? When you are having two different proposal, let me take it as proposal number 1 and proposal number 2. Okay, proposal number 1 will cost so much and proposal number 2 will cost so much. When this option you are having, based on the economic analysis, which proposal will cost least amount, this calculation is called as economic analysis. Okay, with this small introduction, let me start with today's explanation. Okay, now in order to do this economic analysis, we are having two type of formula. Formula number 1 is formula to find out annual cost when salvage value is not given. You may get the doubt, what is the meaning of salvage value? Salvage value means you take any material or certain material, after usage of that material it will cost certain amount. If I take aggregates in the road, even though usage of that aggregate in the road for about 15 or 20 years, you can reuse that aggregate for certain cost, you can save certain cost. Okay, any material which will have certain weightage even after usage in terms of money, that is called as salvage value. Okay, in case in the problem if they didn't given this salvage value, this is the formula what we are using. C suffix r is equal to p multiplied by I into 1 plus I to the power of n divided by 1 plus I to the power of n minus 1. And here the thing is, for this second expression, you may call it as CRF, where CRF stands for, as I already explained, capital recovery factor. Okay. Now, in case if salvage value is given in the problem means, if salvage value is given in the problem means, this is the formula you need to use. CR is equal to C minus Vs into CRF. You are already having the expression for CRF. CRF is given by I into 1 plus I to the power of n divided by 1 plus I to the power of n minus 1. Here plus I into Vs. Here what are all the terminology stands for? P stands for initial cost of improvement, I stands for rate of interest, and N stands for period of time in number of interest periods. Okay, and also in the second expression here C stands for total investment on construction, and Vs stands for, that is V suffix S stands for salvage value. I repeat, here we are using two formulas in the economic analysis. When salvage value is not given, you have to proceed with the first step. When salvage value is given, you have to proceed with the second formula. Now the thing is, how we have to use this formula practically. Okay, in the field how we are using this formulas. To understand this straight away, I am going to use, or I am going to take one problem. Okay, let me take one practical problem. This is the problem. What this problem states here: determine the relative economics of two types of flexible payment by annual cost method from the following data. Okay, here two payments are there. One is payment type A and payment type B. Okay, some data they had given for payment type A and payment type B. Okay, here total cost you have to invest in order to construct payment type A is 3.3 lakh. Similarly, to construct payment type B, you have to invest for about 6.2 lakhs. Okay, design life of payment A is 5 years and design life of payment type B is 12 years. Annual rate of interest, that means the interest you have to pay annually. Yearly, how much interest you need to pay, that is data what they are given. For payment type A, it is 10% and payment type B, it is 9%. Similarly, salvage value of the materials used in the type A payment, okay, that salvage value is how much? 2.1 lakh. Payment type B materials will have a salvage value of how much? 3 lakh, as given in the problem. And also Payment type A maintenance cost is 0.4 lakh per year, and payment type B maintenance cost will be 0.2 lakh per year. This is the data what they are given. We are having different investment for payment type A and payment type B. Now what is the task is, out of this payment type A and type B and the investments what they had given, which one is economically viable? That means which payment cost less per year, or yearly investment is less for which type payment. Okay. Now, in the economic analysis, as I explained in your previous slide, we are having two formula. One formula when they had given salvage value, and another formula when they had not given salvage value. In this problem here, you can see they had given salvage value for both the payment. Therefore, straight away you have to use second formula. Just we will have an eye on the second formula. What is that formula? See, formula to find out, you can observe the second formula what I had written. Formula to find out annual cost when salvage value is given. The formula is CR is equal to C minus VS into CRF plus I into VS. Okay. Now what we have to do is, we will copy this formula to the next slide, and we will check whether all data is available in the problem to solve or to do economic analysis. Okay, I will write the same formula in the next slide, and also here CRF is given by this second expression. Okay, I will write the same formula in this slide. Okay, you can see the formula. So formula when salvage value is given is what? CR is equal to C minus V suffix S into CRF plus I into VS. Okay, where CRF stands for what? CRF is equal to I into 1 plus I to the power of n divided by 1 plus I to the power of n minus 1. Now we will just see, formula is there, we know what T stands for, what VS stands for, what CRF stands for. We just see whether all data is available in the problem to do an economic analysis. Okay, C stands for what? Total cost of investment. It is available, correct? No, for payment type A it is 3.3, and for payment type B it is 6.2. No issues. Next, VS stands for salvage value. Salvage value for payment type A is how much? It is 2.1 lakh. For payment type B it is 3 lakh. So salvage value VS is also available. CRF is given by this expression. Here I stands for interest rate. So interest rate, see, you can see annual rate of interest, it is available for payment type A, it is around 10%, and for payment type B it is around 9%. That data is also available. Now N stands for here, N stands for design life in years. For payment type A it is 5 years, and for payment type B it is 12 years. So all data is available. Again here I stands for interest rate, the same 10% and 9% for type A and type B payment you have to consider, and VS stands for salvage value for payment type A and payment type B you have to do. Now what we have to do, you apply this formula for first payment type A once you finished with the payment type A, apply the same formula for payment type B. I will show the calculation in the next slide. Yes, here you can see annual cost of payment type A. Annual cost of payment type A is given by the formula. Here I had written the formula. Here as I substituted all the things, CRF is calculated separately here. I got this value. Okay. To this annually you are investing certain maintenance cost. You have to add that maintenance cost also. In the problem they had given maintenance cost also for both the payments, correct? No, here you can see at the last row. So after doing all the calculation, you have to add maintenance cost for both the payments. Payment type A, what is the maintenance cost? Payment type B, what is the maintenance cost? You need to add that. Okay. See, you can see I did all the calculation by using this formula. C stands for 3.3 lakh as given in the problem. Salvage value is 2.1 lakh. CRF I calculated separately. 10% is the rate of interest. Okay, N value is 5 years. I just substituted the things in the formula. I got the value as 0.2638. I substituted here, plus I into Vs. I for payment type A, that is interest rate is 10%. I substituted, and 2.11. Okay, that is salvage value I substituted here. To this extra I added maintenance cost of payment type A is as given in the problem. It is 0.4. Therefore, yearly you have to invest for about 0.9266 lakhs. Okay, that means yearly investment on payment type A is how much? 0.9266 lakh. Let me check what is the yearly investment of the payment type B. Same calculation I repeated again, but the data I considered for payment type B. But at the end here I got the answer as how much? 0.917 lakhs. Okay, payment type A, what is the value you got? 0.926. You can see at the end, for payment type A you have to invest for about 0.926 lakh per year. For payment type B, after all calculation I got that here the investment is how much? 0.917 lakh. By observing both, okay, type A is around 0.926 lakh. Here payment type B is around 0.917 lakh. Here which is the lesser? This is the lesser. Correct, no? That means lesser the investment, obviously it is economically viable. Correct, no? For the same road, just an example I am giving, for the same road, one person will give a proposal of 10 lakh and another person will give a proposal of 5 lakh, the same quality of the material. Then which proposal you will choose? Obviously the proposal, second proposal you will choose, because less amount with the same quality. Therefore here what I am saying, since annual cost of payment type is lower and therefore economical when compared with payment type A. Now this is not B, this is payment type A. Okay, and this completes economic analysis part in highway financing. I hope all of you understood this problem completely. Okay, thank you. We'll meet in the next session.